Okay, welcome everyone to the second talk in this afternoon track. We're now going to have a talk about encapsulation with descriptors by Luciano Ramalho. It's a 30-minute talk slot. There'll be 25 minutes of talking and 5 minutes for questions at the end. Please make Luciano welcome.
Thank you very much, Richard. I've been using Python since '98 and teaching it since '99. And as a teacher, I like to focus on some aspects of the language that are different from other languages that people may have learned before. And descriptors is certainly one of those aspects of Python. But before I get into the subject, I want to make a little announcement that this year in October, we are going to have our 9th Python Brazil conference. And it's been great. We've had a lot of foreign speakers in the other editions as well. And this is actually going to be co-located with the PLONConf. The worldwide PLON conference is going to be co-located in the same week in Brazil. And both conferences are going to be followed by a wonderful Caipirinha sprint in João Pessoa. So I want you to look it up, Python Brazil and PLON conference this year. All the information is there. It's going to be awesome. I hope to see many of you there. So, on to the subject. I make a few assumptions here, that you know the basics of how classes and objects work in Python, the difference between new style and old style classes. If you're using Python 3, you don't need to worry about that. That's gone. How to use super, the difference between class and instance attributes and attribute protection via name mangling. I'm actually going to explain a little bit about that. But to give a sort of a real-life context to the talk, imagine that you have a scenario where you're developing this e-commerce application to sell organic bulk foods, right? So you have the classic line item abstraction, right? So you have this order, and there are the line items. Each item has a description, a weight in kilos, a unit price per kilo, and a subtotal for that line. So what is a first implementation of that in Python? The most natural implementation of that in Python. And I actually developed this exercise in a TDD style, and I like doc tests a lot to do TDD. So this is a description of what I want to accomplish. I want to be able to instantiate a line item, and then I want to be able to ask the weight, to access the weight as just a simple attribute, the description, the price, and also have this subtotal method that will give me the subtotal for that line item. Okay, so that's the simplest thing possible. Here's a little UML diagram just to show how it would go. And the implementation, as simple as possible, the way we like it in Python, right? Now, perhaps this is a little too simple, because what happens if somebody orders a negative weight of some food? Then there's a negative amount in the subtotal column, and that's going to generate problems, right? You may say, this is silly, this would never happen in the real world. So you're wrong. Because I actually found this quote while researching for this talk, and it's from the Wall Street Journal, so it's probably true, that they actually talked to Jeff Bezos, and Jeff Bezos actually told them that early on at Amazon, you could actually order a negative quantity of a certain book, and they would credit your credit card. So it may happen. It has happened. Okay, so what is the way to do that? You need to have some control of setting those attributes to do validation, right? So the classic solution is to do a getter and a setter, right? This is okay. But now, if that first simple version had already been deployed and other parts of your system were using that class, this would break a lot of code, right? Because now people can't any longer access the weight as an attribute. They have to call this getter and setter, right? And also notice that I'm using the protected attributes in weight, the double preceding double underscore, those double underscore prefix, That makes it protected, right? So, but the problem is it's a breaking change. You can't, those tests before won't pass anymore. And so what is the one way of doing it? I'll just explain what the way is, but just a little parenthesis about protected attributes in Python. So protected attributes in Python are not about security. They are about safety. It's like a safety switch. This red lid is not there to prevent some malicious person from changing from toggling the switch. It's just there to prevent somebody from accidentally doing that. So that's the whole philosophy of protected attributes in Python. People get scared because it's so easy to access them, like I'm doing it down there. But if you're doing that, you're doing it on purpose. You really want to do that. So it's okay, you probably know what you're doing, right? Anyway, so now back to the original problem. So what we want to happen is this. If somebody tries to set a negative weight, okay, this looks like a violation of encapsulation, but this doc test shows that somehow the business logic is being enforced, so a value error is raised, and then you notice that the weight actually has not changed. This is what we want to accomplish. So a basic way of doing that in Python is to implement a property. So now I use this funny annotation that I invented in UML. You're allowed to invent some annotations in UML. So I invented this property annotation, correct? So weight now is a property. And the way it's implemented is you still have the getter and setter, but you have this descriptor called at property on top of the getter. And the getter and the setter have the same name as the public property. And then you have this other descriptor at weight dot setter. So, and in this case, I'm going to use this later on also. The idea of having two different UML diagrams to show the same abstraction, because in different levels of abstraction. Here I'm just saying this weight is a property. Now, in this other diagram, I am describing the actual implementation. So I'm saying that there is a underweight attribute, and there are the getter and setter for the property down there as methods. Okay? So notice that the private attribute is not accessed outside of those methods. For instance, in the under init, I just set weight and price, and everything happens automatically in the background. That's the way you should use it, to really use the protected attributes only inside the methods that need them. Okay, so now, but what happens if we need to protect price in the same way? Now we would have to repeat the same logic of the getter and setter, and in this case it's the same logic. I just care if it's, I don't want negative numbers. That's basically my constraint here that I want to enforce. So, and this leads to the third and final part of the talk, the main part of the talk, where we talk about descriptors. So the idea is that I need this abstraction that in Python was called a descriptor. And the idea is that those descriptors will manage access to the weight and price attributes. And this is how it's implemented. I'm going to show this code a lot of times, so don't worry about reading it right now. I'm just showing you the main thing that you have to understand from this slide is that you have now this other class called quantity, which is the implementation of the descriptor. And you have a new style class that uses it. Okay? So you may think, oh, this is a lot of code, just for doing a getter and a setter. Yes, but if I put this in a module by itself, then I can easily reuse it everywhere. And in fact, this is the way that Django works, for instance. How many of you use Django? Great. So now you're going to have the opportunity to understand what happens behind. When I started using Django, I actually didn't know about descriptors, and I found that syntax of assigning an instantiation of something to a class attribute, like you said. You see, first line of line item, weight equals quantity. So I'm instantiating this thing and assigning to a class attribute, and magically it works. Now I'm going to try and show you how it works and how to do your own descriptors. So again, a more detailed view using UML is that you have the line item class on the left side and the quantity class. And those underlined attributes, weight and price, they are class attributes. In UML, that's what they mean, the underline. So this is the idea. Now, when I wanted to illustrate this using UML, I discovered that UML is not very good at showing the relationship between classes and instances in the same diagram. And we need this here. Why? Because what happens is, if you look at the code, the line item class, the class, has two instances of quantity attached to it. And, okay, this is pictured here, but may not be so clear. So then I decided to invent this other notation. And just to make clear, because all the time now, and in fact, when you're doing metaprogramming in an object-oriented language, you have to, keep straight the separation between the instances and the classes, and sometimes there's like in this case, there's a relationship between instances of one class and the actual class, or the actual other class. So the line item is that machine that makes those line items. Don't they look like line items? Okay, and the quantity is this other machine that makes the descriptors. Notice that the descriptors have two tools in their arms. One is a lens that they use to inspect the value, and the other is like a hook that it uses to change their value. Okay? So it's the getter and the setter arm. Anyway, and this is my whole point. The idea is that the line item has two descriptor instances attached to it. Okay? And now, if you take a look, see, the characters are in the listing. So you have the descriptor, that class, and this other class down here, the line item, and you see the managed attributes, which are those two little guys down there, right? And an important thing to understand is that the quantity instances are created at import time. So what is import time? Is when Python first reads a module. That's when the functions, the top-level functions are defined, and the classes, top-level classes are defined, and so on, right? So, and this will create some complications later. So each quantity instance manages one of the line item attributes, and every access to the public attributes, weight and price, actually goes through their descriptors. And again, when I'm doing self.weight equals weight here, the description machinery is being activated to do that, to handle that. Okay? Now let's take a look at the implementation of the descriptor. Basically, a descriptor in Python is any class that defines $get, $set, or $delete. This is what a descriptor is in Python. And the tricky thing here is that self in the code of the descriptor doesn't have anything to do with the line item. Self is the descriptor itself, is the little red guy. Okay? And one of these instances is bound to weight, and the other is bound to price. So self is a descriptor instance that's bound to either of these. On the call to set, the instance attribute argument there, this is the instance of the line item that is being handled. See? So now I hope it makes sense to see why the set and the get and the set have those that signature. So to get, you need self. I actually have, because there's another, to get, you need self, which is the descriptor, instance, which is the instance that you are manipulating, and owner. Owner is interesting. Owner is the class to which the instance belongs. And that makes sense if you think about how Python accesses attributes, right? If you access an attribute in an instance and it doesn't exist there, it will access the class. So you need that information to change that behavior or to interfere with that behavior in a way that's compatible with the standard behavior, right? And in the second example, the under set, you just have self, the instance, and the value. You don't have the owner, because when you set an attribute in a Python instance, that is going to be set in the instance, it's not going to affect the class, right? So makes sense also that this is the signature for that method, right? So in talking about this, I had to invent this name of, well, also reading the documentation, I think I found this name, the idea of the target attribute. So the target attribute is where the actual data is stored. So when you set something, then the set gets activated, but you have to store that information somewhere. And so where am I storing it? That's the whole thing that's going on in the dunder init of the descriptor. Okay, the problem is I need to figure out the name of an attribute in the line item instance where I'm gonna store the value. Okay. See, because I need that name to use the getAuthor and setAuthor built-in functions to do that, to actually store the value. So, but the thing is, so this is like I was saying, the target attribute has to have a name that I'm calling the target name. But how do you determine that? What I did was I'm creating a unique name by using a formula that includes the name of the class, which is the class of the descriptor, in this case quantity, okay, and just a counter that I increase. So if you inspect an instance, you're going to notice that this raisins line item instance has an attribute called under quantity under 0, and the other attribute is under quantity under 1. Right? So this is how I am doing it. Probably you would think there's a better way to do it, and there is, but it's much more complicated. I'm going to talk about that. Okay. So the important thing is, even though I'm using this non-descriptive name, this is not really relevant to the users of this class, right? Because for them, they're just accessing these public attributes. Now, how could we improve that? So it would be really great if the target attributes were given, better names. In fact, even better if they were like, use the syntax of protected attributes that Python uses, right? Now, the problem is, to do that, I need to know that name weight. And this is where things get really complicated. Because what happens is, the way Python builds a class is, it first has to read the body of the class. And when it reads the body of the class, the interpreter creates a dictionary of everything that's inside. And then it will call type, which is the metaclass, which is the class that creates classes in Python, passing whatever is in the body as an argument. Okay? So, and in particular, if you think about the way assignment works in Python and most object-oriented programming languages, the right-hand side of an assignment happens first. So the quantity descriptor is instantiated in memory, and then after this object exists, it's assigned to the variable. So when the object is instantiated, it doesn't know what name is going to be assigned to. There is no place for it to look for this name. Okay? So, anyway, the thing is, I started this presentation, we are in the third step. My idea, when I first developed it, was to have 5 steps. And in the 5th step, we would do an implementation using metaclasses that solves this problem. But that just doesn't fit. I tried. I have given this talk before. It doesn't fit in half an hour. It barely fits in 45 minutes, really. So in order to know how to really solve the problem, you need to study about metaclasses. And metaclasses are those machines that make these other machines that in turn make the instances that your program uses. But I would be happy to discuss that with you. Actually, I'm thinking of doing an open spaces session right after the last talk today. So if you want to join me, I'll be there. And I have the slides for steps 4 and 5. But I actually think that in many cases, that other part, the complexity of the metaclass is not worth it. Because the way we solve the problem here, there's an alternative solution also. Instead of using a counter, you can use just the ID of the descriptor instance, which is also a unique number. And you can do that to identify, to distinguish between the different target attributes. Here's another implementation that's viable. And sometimes that's all you need. You don't need metaclasses to do interesting stuff with descriptors. So that was basically it. I'm going to give you just some references. The Python in a Nutshell by Alex Martelli, even though it's about Python 2.5, is still the best Python book in my opinion. And it's highly relevant because Python has not, don't believe the things that people are saying, that Python 3 is a completely different language. No, it's 98% and on the surface, the same language. Anyway, so this is, and also there's David Beasley's. And by the way, just my last point is that this is really elegant. Every Python function is a descriptor. Every Python function has a dunder get and a dunder set attribute. And this is how, when you access a function through a class as a method, it becomes a bound method. Because the default implementation of the dunder get for a function does a partial application of the function with the self. Okay, this is really elegant because then, so we have, I think this is really elegant because we have this abstraction machinery in the language that you can use to solve real world problems like the one I described, but it's also used to implement mechanisms in the language itself. So that's why I love Python. That was my presentation.
So 2 questions quickly then. The first, the signature of the getter and setter methods on the descriptor itself, they take owner, which is the name of the class whose instance you've been passed. And I'm curious why you need owner, since you could look it up on the instance. Would there ever be a case in which, I was trying to think if there's a case in which instance _class would not be the same as owner, and would that ever be true?
The thing is, you're trying to emulate, this API allows you to emulate the behavior the standard behavior of attribute access in Python. And the standard behavior is, if you have an object O and you access O.x, it will first look at in the instance, and if not, then in the owner of the instance, the class.
True, okay.
So this is why that's there.
Well, and that then led, I guess, to my second thought, which is the issue of figuring out what's the name of the property that holds self in the get, right? Self is going to be the instance of the descriptor, and I'd like to know what name it is on owner that holds that instance. Couldn't I look at owner's attributes and find the one that is self?
That's step 4 in my presentation.
Step 4, okay.
But there's a severe performance cost for doing that. And this is the reason why we need step 5, which is the metaclass. But actually, like I said, probably you don't need either step 4 or 5. This is fine.
Hey, on the slide right here, I was wondering why you didn't just keep the value of the property that you're working with here just in the quantity instance. Why you feel like you need to set it in the instances, in the remote instance?
This is an excellent question. What's your name?
Jared.
You just saved me because I actually should have said that. I should have explained that. But this is really an excellent question. And the reason why is that, like I'm trying to explain with all these drawings, is that the quantity instance, so this self here, points to something that is assigned to the line item class. So if you store any data in this instance, it will be a class-wide value. Every instance of line item will share the same value for that quantity. If you store it in, did you get it?
Yeah.
So yeah, but this really was an excellent question. Thanks a lot for asking it. Yeah. And it's actually the first surprise. The first implementation is like you said, you do that and then there's this weird behavior and then this is the solution.
This is a follow-up to the previous question, actually. What if you just made the quantity objects belong to the instances rather than the class itself? Then can't you? Do you see where?
Well, then you would be instantiating a lot more objects than you need.
Right. Okay.
And actually, it wouldn't work that way either because the mechanism for descriptor is implemented in the class level.
Okay.
Yeah.
So thank you, Luciano.
Thanks a lot, guys.